Hello everyone, welcome to this video. In this video, we'll be solving question 2 from exercise 10.1. Right, so the question here is the base of equilateral triangle is given to us with side 2a, right? So, and it lies along the y-axis such that the midpoint of the base is at the origin, correct? So, for instance, let's not see these diagrams. So the question here is the base of equilateral triangle with side 2a, it lies along y-axis. Now what you can do, you can draw a coordinate axis with your y-axis here and x-axis here, right? Now they are saying we have an equilateral triangle, correct? So therefore each side measures 2a, right? This is known to us. Now what they are saying, what is the orientation of this triangle? It is lying with its base such that the midpoint lies at the origin. So suppose this is the base here, its midpoint is this point where the distance from here to here is a and from here to here is also a, and so they are saying this is lying at origin. So what we can do, we can draw a length of 2a such that this is the midpoint and this much length is a, this much length is also a, right? So this point would be a, this point would be minus a. Now the other two sides, it could be along these this, or it could be like this, right? So in either side you can have your this equilateral triangle. So let me just show you how it will look like. So here is the orientation. Here you see in figure 1, your triangle could be lying along the positive x-axis such that you don't know what is the altitude here, this much length you don't know. However, you know the sides, you know what is 2a and you know what is 2a, correct? And here the distance, let's mark this as origin. Obviously you know it is origin. Let's mark the other points as a, b and c. Similarly for the other triangle, right, if you have this as 2a, right, and both the other sides could lie on the negative x-axis, right? We do not, in this case also we do not know what is the altitude here, right? So here they are asking what are the coordinates, find the vertices of the triangle. So we need to find the coordinates for the triangle ABC. So we have to find what is the coordinate of A, what is the coordinate of B, what is the coordinate of C. Okay, so by looking at the figures, we can very easily identify the coordinates of A and B. If you look at the first figure here, what for the coordinates of A, you see your x distance is 0 because it is lying on the y-axis. So here we have 0, and similarly for the point B, you do not move in the x direction, you only move in the y direction. So therefore your x coordinate here is 0 as well. But how much is this distance? This is A for capital A. And what is this distance? It is the distance A traveled in the negative y direction, so it is minus A. So you know the coordinates for A and B, they are the same in case when you take either case 1 or case 2, correct? So this is what I have written over here. Let me show you. If we have our vertices lying on y-axis and we call them as A and B, then the x-coordinate of both A and B would be 0. Why? Because it is lying on the y-axis, right? And the other coordinate, the y-coordinate is determined by the length on either side of the origin. So you know the length, it is A and A. So the coordinates are 0 and A and 0 and minus A. Now in order to determine the coordinates for the point C here, what do you require? You see your point C lies on x-axis. So that means no distance in the y direction has been traveled. So that means y coordinate is clearly 0 for the point C. Either you are in the first case or in the second case, correct? So therefore for C the y coordinate is clearly 0. Now the remaining part is we have to calculate what is this coordinate x, right? So in order to determine the x coordinate, we require the length from the origin which has been traveled in both the cases, right? The length would be the same, however the orientation, the direction would change. If you take the first case, it would be positive, and if you take the second case, it would be negative, right? So you see here, let me clarify the figure first of all. So you can see here we have a right angle triangle forming here, right? With this as the right angle. Hence we can apply the Pythagoras theorem here. We have the perpendicular distance with us, we have the hypotenuse, and we do not have the base. So very clearly it would be equal to OA square plus OC square. This would be equal to AC square, right? This is what I have written. Now we know the value of OA, it is A. We know the value of OC, right? This is what, this value we do not know, so let's keep it OC. And what is the value of AC? You know the side of triangle is 2A, so it is 2A. So substitute the value, solving the values here, shifting this term to the right hand side and evaluating the value of OC as square root 3 into A, right? Now notice that this A is not under the root, it is separately written with square root 3. So therefore when you are traveling in this positive x direction, so therefore the point would be square root 3 into A in positive, right? So this would be your point. And when you are traveling in the negative x direction, as in this case, so your x point would be minus square root 3 into A comma 0, right? So you have these 2 points whenever we have different orientation of the equilateral triangle. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.